Hi, I am Puya Pezeshpur, and unfortunately, because of visa issue, I couldn't be there with you fine people. And as a result, we decided to present our work in the form of recorded video. So today I'm going to talk about embedding multimodal relational data for knowledge-based completion, which is a joint work by me, Leon Chen, and my advisor, Professor Samir Singh. So one of the most important tasks in knowledge graphs is basic knowledge graph completion, which can be defined through two different scenarios. The first one is entity prediction, which can be defined as predicting or generating missing entities based on a specific relationship. And the second one is actually the link prediction task, which can be defined as predicting missing relationship between two entities. So for example, for link prediction, if we know that Barack Obama is married to Michelle, and furthermore, we know that Barack Obama has a daughter, Sasha, we should be able to conclude that Michelle has daughter, Sasha. Accordingly, to be able to do the graph completion task, one of the directions is to represent the graph in the vector space, which will enable us to encode all the information about the entities, predict the missing facts, and further find the incorrect triples in our datasets. And to represent the knowledge graph in the vector space, the previous work usually represent the information in the form of a triple, subject, relation, and the object. And then they would usually find a vector representing each one of these components, as we can see in this network. After that, by applying a scoring function on those vectors, they could capture the probability of correctness for each triple. In the past few years, many scoring function has been introduced, but for this work, we mainly focus on two of them, which is dsmalt and conv. Dsmalt because of its simplicity and popularity, and conv because of the fact that it has a set of odd results on our datasets. So before moving on to our idea, let's see a practical example. So here we see a subgraph of our knowledge graph, which is around the Carlos Puyol. So we see Carlos Puyol is affiliated to Catalina national football team and also is affiliated to Spain national under 18 and under 23 team. And we also see that Carlos Puyol has gender male. So if they ask us which team Carlos Puyol is affiliated to, based on the provided information, we should be able to answer that it is a Spain national team and not Italy national team. But let's see another example. They provide us with the same information, but this time they ask us which team Carlos Puyol plays for, which is the answer is Barcelona or Real Madrid. And both of these teams are from Spain. So based on the provided information, we cannot answer this question. But if they provide us with another piece of evidence, which is the image of Carlos Puyol wearing Barcelona clothes, we should be able to answer this question correctly, which is the Barcelona team. So as we see in the previous example, information can be provided in many different modalities. It can be in the form of relational link, textual information, images, numbers, time series, and it can be even in the form of dates. So the idea of in this work is to use all kind of these different modalities to have a better representation and more informative representation for the knowledge graph. And as a result, we define the concept of multimodal knowledge graph. So for example, here we see we have the information for Carlos Puyol in different type of modalities. We have textual description, we have images for him, and we have born date, which is in the form of number, and we have relational link. So to process all kind of these modalities, we treat each one of them as a first-class citizen of our dataset, and accordingly we treat them as a separate triple. So basically we have a triple with object type of entity, we have entities in the form object entity in the form of textual information, we have images, and we have numerical value. So the question at this point is how we can embed all of these different type of entities. And the answer that we find for this question was to use different neural encoder based on different type of object entity that we have. So for subject and relation, we use a similar approach as previous work, but for object entity, based on the type of object that we are dealing with, we use a different type of neural encoder. Accordingly, as this encoder, for entities, we use a lookup layer. For images, we use CNN layers, and for textual information, we use LSTM, and for numbers, we use a simple feedforward, and using these layers, we would find a vector representing each one of these different type of object entities. Since the dataset in the previous work didn't have these extra type of modalities, we forced to make our own two new datasets. We firstly use MovieLens 100K, which is a recommendation system dataset which have rating between user and movies. And furthermore, this dataset has information for movies like genre and release date, and further it has information for users like gender and age. And we, in addition to those, we enrich this dataset with adding posters to this dataset. And in addition to MovieLens 100K, we use a Yago 10 dataset and actually enrich it with numbers, descriptions, and images. The statistics of the extra modalities is provided in these tables. And to evaluate our models, we conduct a link prediction task on our two dataset. Here we see the result on MovieLens. We evaluate our models using ranking metrics. Here we see the result for MRR for our two scenario, D small time conv. And as we can see, by adding extra modalities into the models, which is user info, and then adding the titles, and then adding the posters, we see the improvement in our results. It seems the posters didn't have that much, it wasn't that much useful for our model, and probably that's because of the fact that the number of posters is not that much. And overall, we see the improvement of 4% on rating prediction based on MRR metric. And we conduct similar experiment on Yago dataset. Here, we see our result on HitStat1, which is another ranking metric, and the same thing happened here as well. By adding extra modalities into the model, we see the improvement on our ranking result. And overall, we could achieve 40.8% improvement on these metrics, and actually we could achieve a state-of-art result on this dataset for these ranking metrics. By that, we finish the link prediction task and move on to entity prediction task. So basically the goal here is to generate the missing attributes for specific entities based on all other observed facts that we have for that entity in our knowledge base. So for example, here we want to generate the missing images and missing born date for Carlos Puyol based on all other information that we have for him in our knowledge base. And accordingly, to do that, we use the learned embeddings of entities from link prediction task, and then applying different neural decoder to those embeddings, we will generate the missing attributes. So specifically, when we want to generate missing numbers, we use neural regressor, and when we want to generate missing text or missing images, we use conditional text or conditional image GANs model. And here we see our conditional GAN model. So basically using the observed information in the data, we find the embedding for each subject, and then by feeding this embedding to generator and discriminator part of our GAN model, we would generate missing images and missing descriptions for each subject. To evaluate our neural decoder, we conducted several generating missing attributes experiments. On the left, we see genre prediction task. Basically, we remove several genre from movies in our dataset and try to predict those genre using other information that we see in the data. And as we see in the chart, by adding extra modalities, the result of accuracy become better and better. And on the right side, we see a birth and death years prediction for Yago dataset, and we evaluate our models using RMSE metric, And as we can see, the same thing happened here too. By adding extra modalities into the models, the RMSE prediction become better and better. And in addition to these experiments, we try to evaluate our model for generating missing textual information as well. Here we see some of our generated samples. So what we did, we removed some of the description from dataset and try to generate them using the other information that we have for each one of those subjects in our data. As we can see in these samples, our model could capture the gender of subject, it could capture the occupation, and almost it could capture the born or other kind of dates that we have in the original description. So here we see our user study on generated descriptions. We provide 30 examples for each model and ask each question from 3 participants. Here we see our 4 model. We have majority of the data. We have generated description using only relational links. We have generated description using all of the info. And the last one is the reference description. So we asked 4 different questions from each user. We've asked them whether they find the generated description real or fake. We asked them whether they could guess the gender of the person, and furthermore, we asked them if they can guess the age of the person. We provide them with 2 choices, less than 35 and more than 35. And lastly, we asked them if they can, guess the occupation of the person using that generated description. And we provide them 3 choices, whether it is a sport person, whether it is celebrity, and whether it is politician. As we can see in the data in the experiment, the generated description using all of the information, all of the modalities, provide us with a very good result. And it actually is very close to the reference results. And similar to generating missing description, we try to generate missing images for Yago as well. Here we see 3 different categories of subject. We see the sports people, we see male celebrity, and we see female celebrity. And for each one of them, the top one is the reference image, and the bottom one is actually the generated images for those actual missing images. And if you look at this data, our model, we could see that our model could capture the gender and somehow could capture the occupation as well. So for sport people, we see the background has the green color, which is somehow try to capture the football field, and we see the celebrities has more formal attire comparing to sports people. And here we see our user study on generated missing image for Yago dataset. The same as our description experiment. We provide 30 examples for each model and ask each one of questions from 3 participants. The same as before, we have 4 type of models. We have majority, generating images using only relational link, generating images using all the information, and the last one is the reference result. And we asked 4 questions. We asked about the realness of the generated image. We asked about the gender of the image. We asked about the age of the person in the image, and we asked about the occupation of the person in the image. So as we can see, again, similar to previous experiment, having all of the information while we are trying to generate the missing image provide us with the best result. It seems that the images are not very useful in age and occupation category, but again, it still provide us with the better result comparing to other models. By that, we finish the entity prediction task as well. So overall, in this work, we talk about injecting multiple modalities into the knowledge graph, and then using different neural encoders, we try to have a better and more informative representation of knowledge graph. And then using these learned embeddings from link prediction tasks and combining it with different neural decoders, we try to generate the missing attributes in our knowledge graph. And by that, I finish my talk. Thank you for your time. Here you can see our website, which has the links to the code demo and the data, and this is our contact information. Thank you for your time.